Welcome back. In the previous lecture, we understood what are the data frames and what are the partitions at a high level. Now that we understood how to hold the data as a part of these data frames, what do we do with the data? That is what we will discuss as a part of this topic. Let us get started. Assuming that we have a core data structures. When I say core data structures, we are talking about either a data frame or a data set or a RDD, all these things. To make it more clear, are data sets or even RDDs. When we are talking about all these core data structures, a question for you guys: are they mutable or they're immutable? Can you pause a video and just answer this question? You know they're immutable. All the core data structures, whether it may be a structured API or low-level APIs, all of them are immutable. Now the question comes, if you can't change it, means immutability means once you create the data frame, you will not be able to change it. If we cannot really change it, how are we supposed to use them? That will be the question, right? To really use the data frame, what we need to do is we need to instruct a Spark how would we like to change it or modify it. To just to repeat, in order to change a data frame, we would need to instruct a data frame how do we really want to change that or how do we really want to modify it. These instructions which are instructing the Spark to modify or change a data frame are called as transformations. Just to repeat, the instructions which are being instructed to change or to modify the data frame are called as transformations. If you really see, in most of the Spark, you will be using these transformations left and right. In a way, these are the core operations through which we express the business logic to process the data. So transformations are very, very important. See, look at this. We have a very simple transformation here. Before we really get into the transformation, let us try to create one simple data frame. After creating the simple data frame, we'll go ahead and apply some transformation on top of that. Let me quickly get into my PySpark. So I'm invoking my PySpark. Now my PySpark is invoked. What I will do is I'll create one data frame named my range. My range is equal to Spark. Do you remember we have to go through Spark session always? Spark dot range is a function which I am calling, and let us try to get some 10 numbers. And we use something called 2df function here, and I'll give the name of the column. This is how I'm creating a first data frame. Look at this. This is the first data frame which we are creating as a part of this course. Aren't you excited? Yes, you are. Let me say how to see the data frame. My range dot show. Yeah, there you go. We have our first data frame created and we have one column and 10 rows. Now that we have a data frame, let us try to understand what is transformation. Here in this case, what I am trying to say here is my range is my data frame. On this data frame, I am applying a transformation called where. Where is a transformation here? And the logic what I am trying to give here is number is the column of my range data frame, and on that I am trying to see whether each of the number is divisible by 2 or not. So for this data frame, I am applying this transformation. This is the transformation. And this is the logic on which I am applying. Okay, let us go and see this in action in a PySpark. So we have a data frame. So let us name the data frame as divis by 2, and we'll say my range dot where we'll just give the logic of the transformation. So number is modulus of 2 is equal to 0. That is what we are trying to do here, right? Okay, let's go and execute this. There you go. You got your transformation logic executed. If you go and look at in the resultant data frame, we'll be able to see all the numbers which are only divisible by 2, 0, 2, 4, 6, 8. This is how the transformation will be happening as a part of the Spark. Now that we understood how to create a data frame, we created a first data frame, yay! And then we applied a first transformation. In the transformations, there are two types of transformations. One is a narrow transformation. The second one is a wide transformation. Let us see them one by one. Narrow transformations, what really is happening here is, if you see, we have a input and output. What happens is, usually you do a data processing task on an input partition. So processing happens and it will generate the output, right? When the processing happens, if one input partition is contributing to only one output partition, that is where we call it as a narrow dependency. So only one input partition is contributing to the only one output partition. This is what we call as a narrow transformation. And when we have a narrow transformation, what happens is we'll be able to pipeline the activities nicely because there is no shuffling happening here. That is the reason. Let us take one example on what are we discussed now, what are the data frame we created, and try to understand this narrow transformation. Let me take you to the Microsoft whiteboard. I hope it is visible, clear to all of you. Assuming that our data frame has some 100 values. See, this partition has 0 to 24, this partition has 25 to 49, this partition has 50 to 74, this partition has 75 to 99. So when you apply a transformation, see, as we already discussed, this is a right? The transformation is being applied to all the partitions. So what happens is, in this case, what we are trying to do, the modulus of a number. A resultant set of this output partition would have only the filtered numbers of 0 to 24. Means 0, then 2, then 4, then 6, then 8, then 10, so on until 24. Only this partition is contributing to this partition. This is where we call it as a narrow transformation. I hope you got it really well. Now that we understood what is narrow transformation, let us try to understand what is wide transformation. By this time, you would have already understood what may be a wide transformation. What is happening in a wide transformation is, one of the partition is contributing to more than one output partition. For example, this partition 1 is contributing to partition 1 also, partition 2 also. Because of this, there will be shuffle. For example, assuming that we have a partition 1 in system 1, partition 2 in system 2, partition 3 in system 3. The same is the case here. Output partition 1 would be in 1, 2 and 3. I am saying systems. System. So now what is happening here is, because partition 1 is contributing to the output partition 1 and also input partition is contributing to the output partition 2, there is a movement of the data between the systems, right? That is where the shuffle is happening. This is what is wide transformation is. I hope you enjoyed the session. Thank you.